We are a curious species. It's written into our very being, a fundamental part of what makes us human. Look up at the night sky. What do you feel? For millennia, we have stared into that vast, dark expanse, dotted with impossibly distant points of light, and we have wondered, what are they? How far away are they? Are we alone? This relentless desire to know, to push beyond the horizon of our understanding, is not just a passing fancy. It is the engine of our civilization. It drove our ancestors out of caves, across continents, and over vast, uncharted oceans. It is the same impulse that now beckons us to the stars, to the greatest ocean of all, the cosmos itself. This cosmic itch is more than just idle curiosity. It's a survival mechanism. By exploring the unknown, we learn more about our own world and our place within it. Every step into the void is a step toward understanding ourselves. In the late summer of 1977, humanity did something remarkable. We took our cosmic curiosity and forged it into a machine. We built a traveler. We called it Voyager 2. Launched just a few weeks before its twin, Voyager 1, this 3-ton marvel of engineering was designed for a grand tour of the outer solar system. It was a mission made possible by a rare alignment of the planets, a celestial coincidence that happens only once every 176 years. This alignment would allow a single spacecraft to use the gravity of one giant planet to slingshot itself toward the next, a cosmic game of leapfrog across billions of miles of empty space. Voyager 2 was more than just a camera and some scientific instruments. It was a message in a bottle, cast into the cosmic ocean. The journey was epic. Voyager 2 sailed past Jupiter in 1979, revealing volcanic activity on its moon Io. In 1981, it flew through the majestic rings of Saturn, but its journey didn't stop there. It pushed onward into the deep dark. In 1986, it gave us our first close-up look at Uranus, a tilted aquamarine giant. 3 years later, in 1989, it encountered Neptune, a world of violent supersonic winds. For 41 years, Voyager 2 sailed on. It moved through a space that seemed empty, but was actually filled with a constant stream of particles flowing outward from our sun. This is the solar wind, an invisible bubble of charged plasma that our sun inflates around itself. This bubble is called the heliosphere, and it's the domain of our star. Everything inside it, all the planets, the asteroids, the comets, is bathed in the sun's material. The heliosphere is our home, our cosmic neighborhood. Scientists knew that somewhere, far beyond the orbit of Neptune, this bubble had to end. They called this boundary the heliopause. It's the place where the sun's solar wind, weakened by its immense journey, is finally stopped by the pressure of the interstellar wind. Voyager 2 was our scout, sent ahead to find this unseen shoreline. On November 5, 2018, it happened. The message, traveling at the speed of light, took over 16 hours to reach us here on Earth. The data streamed into the control rooms, and the scientists watched, breathless. One of the key instruments on Voyager 2, the plasma science experiment, registered a sudden, dramatic change. For years, it had been measuring the speed, density, and temperature of the solar wind particles, and then, in an instant, they vanished. The instrument's readings for solar plasma dropped to zero. This was it. This was the moment of transition. Voyager 2 had exited the heliosphere. As we celebrated Voyager 2's historic crossing, the data kept streaming in, and with it came a profound shock. The models, the theories, the elegant equations that had predicted what the edge of our solar system would be like, they were all, in some fundamental way, incomplete. We expected the transition from our solar bubble to interstellar space to be a relatively smooth one. But what Voyager 2 found was far stranger, more complex, and honestly, more violent than we had ever imagined. As it approached the heliopause, Voyager 2 detected something astonishing. The plasma, the superheated gas of the solar wind, was getting significantly hotter and denser than any of our models had predicted. It was piling up against the interstellar boundary like water building up behind a dam. But there was more. Just before it crossed over, Voyager 2 passed through an unexpected, mysterious layer, a kind of cosmic wall of fire. The temperature of the plasma in this region spiked dramatically, reaching temperatures far hotter than the sun's own corona. Let's try to picture this. Think of our solar system as a boat moving through the water of the galaxy. The heliosphere is the wake created by the boat. We expected the edge of this wake to be a bit choppy, but what Voyager 2 found was more like a raging, fiery waterfall at the edge of our solar system. This discovery was mind-blowing. It told us that the boundary of our solar system is not a simple, invisible line. It is a real physical place with its own dramatic and unexpected properties. The discovery of this superheated plasma wall at the edge of our solar system was more than just a surprising detail. It fundamentally changed our understanding of how stars interact with their galactic environment. For decades, our models of astrospheres, the bubbles that all stars create around themselves, were based on elegant but simplified physics. Voyager 2's data shattered that clean image. It showed us that the boundary is a messy, complicated, and incredibly energetic place. This finding has enormous implications. It means that our sun's protective shield, the heliosphere, is far more complex than we knew. This boundary layer doesn't just mark the end of the sun's influence, it actively filters and modifies what comes into our solar system. It acts as a second line of defense, heating and slowing down cosmic rays from the galaxy before they can even reach the heliopause. Understanding this fiery wall is now crucial to understanding the radiation environment of our entire solar system, which has direct consequences for protecting astronauts on future missions to Mars and beyond. Think of it this way. Imagine your house has a fence to keep stray animals out. For years you thought it was a simple wooden fence, but then you discover that the fence is actually a complex, electrified security system with its own power source and an unexpected moat of fire around it. Suddenly, our view of the galaxy changed. It was no longer a sea of stars and mostly empty space. Instead, it might be a collection of fiery, turbulent bubbles, all pressing against each other, creating a complex, frothy, cosmic foam. Voyager 2 didn't just tell us about our own backyard. It gave us a shocking new insight into the structure of the galaxy itself, forcing us to go back to the drawing board and create new models that can account for this beautiful, violent reality. Every great discovery in science doesn't just provide answers, it spawns 100 new questions. The revelation from Voyager 2 was no different. It was like opening a door we thought led to an empty room, only to find it filled with intricate machinery we didn't understand. The first and most obvious question for scientists was, why? What physical process could create such an incredibly hot and dense wall of plasma at the edge of the heliosphere? This single discovery immediately spurred a new wave of research. Theorists began scrambling to build new computer simulations and mathematical models. Could this fiery wall be caused by a process called magnetic reconnection, where magnetic field lines from the sun and the galaxy snap and release enormous amounts of energy? Or is it related to charge exchange, where neutral atoms from interstellar space drift into our solar system and interact with the solar wind? These were no longer abstract questions. Thanks to Voyager 2, we now have real data from that very region, a ground truth against which we can test our new ideas. To answer these questions, we will need new missions, a new generation of explorers designed specifically to map this incredible frontier. A proposed mission, aptly named an interstellar probe, would be our next step. Ultimately, the most profound effect of this discovery was on our perspective. It was a humbling reminder that we should never be too confident in our models of the universe. The story of Voyager 2 is a story of human ambition and cosmic reality. We built a machine, a marvel of ingenuity, and sent it on the grandest journey we could conceive. We programmed it, guided it, and listened to it for over 4 decades. And in return, it sent us back a lesson in humility. It showed us that the universe doesn't always conform to our expectations. It has its own rules, its own surprises, and its own magnificent secrets, waiting in the dark for a curious mind to find them. The discovery of a fiery wall at the edge of our own solar system is a perfect example of this beautiful cosmic dance between prediction and discovery. This little spacecraft, now more than 12 billion miles away, is a testament to the power of relentless curiosity. It reminds us that exploration is not just about confirming what we already know. It's about embracing the unknown. It's about having the courage to venture into the dark and the humility to accept that what we find there may change everything. Voyager 2's journey continues, a silent ambassador in the interstellar void. It will likely outlive us all, outlive our civilization, a lonely monument to a species that once looked up at the stars and decided to go see them for themselves. The legacy of Voyager 2 is not just in the data it collected or the pictures it took. Its true legacy is in the sense of wonder it continues to inspire. It connects us to the grand cosmic narrative. The universe is not a finished book. We are still in the early chapters, and new, astonishing discoveries are waiting on the very next page. So the next time you look up at the night sky, think of Voyager 2. Think of that tiny, tenacious probe sailing through the darkness between the stars. having revealed a secret about the very edge of our home. Let it be a reminder that we live in a vast and mysterious cosmos, and our journey of understanding has only just begun. The desire to explore is our birthright. The universe is the destination, and the journey, with all its shocking twists and turns, is the greatest adventure of all. Stay curious.